Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is just to give an example of how to evaluate a definite integral. So what we're looking at here is the integral 0 to root 2 of the quantity t minus root 2 dt. And this is going to equal some function evaluated at root 2 minus some function evaluated at 0. Again, provided that we can find that function that has a derivative equal to t minus root 2. So we're going to go through this, and this can be integrated term by term. So the antiderivative of t, you just apply the power rule to it. This is t to the first power. So you would add 1 to the power. That's going to be t squared divided by the new power. Right? Minus root 2. Now square root of 2 is just a constant. Just like differentiation, you can typically just kind of ignore them while you think about the antiderivative part. Now there's no t here, or if you want, you could think of that as root 2 times t to the 0 power, as far as taking the antiderivative is concerned. If you add 1 to the power, that's now going to be t to the first, divided by the new power. So this term has an antiderivative of root 2 times t. Then this is going to be evaluated from 0 to root 2. And again, that's what this bar means or reads, is evaluated. Bottom limit, top limit. So this is going to equal, you put in your top limit, square root of 2 squared minus 2 minus square root of 2 times square root of 2. I'll go ahead and put this in brackets. That's just the top limit. Minus, and I'll put this in brackets, putting in the bottom limit, that's going to be 0 squared over 2 minus square root of 2 times 0. So just go through now and kind of look at this term by term. Square root of 2 squared is 2, divided by 2 is 1. Square root of 2 times square root of 2 is 2. Minus, a pair of zeros over here, I'm just going to put 0 minus 0, I guess, just as placeholders. And then 1 minus square root of 2 is negative 1. So minus 1 is the value of this definite integral from the region 0 to plus 2 square root of 2. Definite integrals can be negative. That's coming from the fact that this function here is negative in that region. And again, when we talk a little bit about areas, that'll become a bit more clear. So the purpose of this video is just how to evaluate the definite integral. Hope that this video helps. Have a great day.